Okay, so we're going to work our way through this. So first of all, 80, scoot over. So B is 80. 50, scoot over the triangle. A is 50. And the reason is alternate segment theorem. Number 2, D, scoot over, is 55. C, scoot over, 65. And again, alternate segment. Down here, can you see triangle? Diameter, that's 90. Can you see the radius and the tangent? So radius and tangent meet at 90. So this angle in here is 90 minus 65, which is 25 degrees. So to work out F, you've got a triangle. So 180 minus 90 minus 25 is going to be 65 degrees. Number 4, scoot over, 42, scoot over, 63. Alternate segment theorem. Oh goodness, there's lots going on here. 42, scoot over, is also 42, and it's alternate segment. Can you see your cyclic quadrilateral in there? The four-sided shape. Oh goodness, mine's not very good there. So J, the opposites add to 180. So it's 77 degrees, and it's a cyclic quadrilateral. And then to work out I is a straight line. So 180 minus your 42 minus your 77. So 180 minus 42 minus 77 gives you 61 degrees, and it's a straight line. And down here, can you see the scooty across one? So that's 51 degrees, and it is alternate segment. Now, straight line to get M, so 180 minus 63 minus 51, and that's straight line. Once you have your rules learned off, it's not too bad doing these. You might see it through a different way to which I use, and that's absolutely fine, no problems whatsoever. Okay, I'm going to try exercise E, if I can curl it up here. Okay, lots of stuff. Straight line, so that's going to be 180 minus that, 50 degrees. Straight line, so wanting you to write down the reasons. 90 degrees, because it's a diameter and a right angle, so it's a right angled triangle. Right angle triangle with diameter. So a whole triangle adds to 180. So 180 minus 90 minus your 50 gives you your 40 degrees. Now, centre and edge. So this one in here, the edge is half the centre. So you divide that by 2, 29 degrees. So circumference equals half times the centre. And then to get B, it's a straight line. Gives you 151 degrees, and that's a straight line. Now, we'll see how we go on over the page with the really hard ones. Okay. Isosceles triangle. So this angle in here is 35. So this one is 180 minus your two 35s is 110. And then C is half the centre. So I'll not write them in because I haven't got space, but basically you should write in there that the C is half of the centre. In this one here, can you see your four-sided shape along the outside of the circle? So remember the opposite angles in the four-sided shape add to 180. So it's going to be 104 degrees, and the reason cyclic quadrilateral adds to 180. Now, you've heard me talking about the humps going the right way. Hopefully this make a bit more sense now. This angle is 104. You see the centre angle? See where this hump is pointing down the way? So that hump is double the F. So E is 104 times 2 to give you 208 degrees. Now if you look at you could do a complete turn there and do 360 minus 208 to get D, or you can do it this way. Can you see the way my hump is pointing up? And my hump is pointing up. So D is double the one at the edge. So double that, 152 degrees. Right, what have we got going on here? I'm just going to ignore that wee bit. Isosceles triangle, 33. So that's going to be 180 minus 66. So that one there is going to be 114 degrees. So the edge is 114. Now, this is a very tricky one. If you start here and finish here, see if I start and go to the edge and come back. See if I start and go to the centre and come back. The way the centre is double the edge. But look, the hump is pointing this way. So your hump has to point this way. So this angle is double the one at the edge. So 228. This is 228. So to work out G, it's a complete turn. So it's 360 minus 228 to give you 132 degrees. Lots going on here on number 6. These are getting very tough. Straight line. So 180 minus 56 gives you 124 degrees. Isosceles triangle. So 180 minus 124 divided by 2. So 180 minus 124 divided by 2. Each of those angles is 28 degrees. So that's 28. And that was 28. The angle at the centre is double the one at the edge. So you see the way the humps are both in the same direction. So the angle at the centre is double the one at the edge. So it's 56 times 2, which is 112 degrees. Number 7, diameter 90 degrees. So remember, triangle adds to 180. So J add 3J add 90 equals 180. So 4J, bring that over and take it away, is 90. So J is 90 divided by 4 to give you 22.5. Number 8, isosceles triangle. You can see in there. So we can work out these angles. So 180 minus 94 split in 2. So 180 minus 94 split in 2, 43 degrees. So this is 43 and that's 43. If you start here and finish here, you go to 43. So K is also 43. Now, this one here is quite a tricky wee one. This is going to be an isosceles triangle because the tangents are going to be equal. So this is 65. So to work out this one here, it's going to be 180 minus your two 65s. So 180 minus 130, 50 degrees. Now, for the next bit, can you see if you ignore all this, I try to cover it up, can you see your scooty across there? So this angle is 65, and that's the alternate segment theorem. Number 10, cyclic quadrilateral. So this angle P is 80, because it adds to 180. Can you see that if I take this out, the triangle, scoot across, angle Q is 65, and then to work out angle R, it's a straight line. So R is going to be 35 degrees. And the last one, we'll just leave that one out. We'll not worry about the last one at this stage.